So we'll just plot the graph. It's just a straight line graph. And we'll join the line. And the next we'll find the intercept. And that the intercept of the two graphs is where is the solution of the equation. So we'll read the values.
Hi viewers, welcome to ONYE-NKUZI Science Academy. On this lesson, I will be treating quadratic graph as a method of solving quadratic equation or function. The graph of any quadratic function is a U-shaped curve called parabola. The orientation of the parabola can be upward or downward, with the above table of values on both sides. Let's plot a quadratic graph of two different orientations, from the left-hand side to the right-hand side. Let's plot the points.
Then after plotting our points, we'll join the points together. While joining the points, make sure your curve passes through the points. Ensure you sharpen your pencil while joining. For you to join the curve, you can use flexible curve or French curve or a local broomstick. Please, if you're enjoying this video, kindly press the like button and subscribe to my channel. Share this video to your friends who will find this video very helpful. Thank you. Now let's define important key features of the quadratic graph. First of all, where the curve cuts across the x-axis is known as the root of the equation, the points, as stated on your screen. Now the next is the lowest or the minimum value of y. You take the reading to the y-axis, and when we go to the right hand side, when the curve, the orientation is downward, you see the maximum or the greatest value of y. That is also the vertex, and we have the line of symmetry drawn at the center where the vertex is. The line of symmetry is equal, when you're calculating it, is x equal to minus b all over 2a. On the vertex, you can see we can also calculate it using the equation on the bracket for the minimum value, and on the maximum value you can also calculate it with the equation. Now let's go to y-intercept, which is equal to c. At the equation it is minus 3 on the left hand side, while on the right hand side it is plus 2. You can see it where the curve cuts across the y-axis on the both graph. So these are the key features of the quadratic curve. Now let's solve a full quadratic question. Okay, from the question, we are asked to copy and complete the following table of values for the relation y equal to 2x squared minus 7x minus 3. So let's do that now. Step 1, we'll have our table. So let's start to complete it. Using the equation y equal to 2x squared minus 7x minus 3 to fill and complete the table, we substitute x in the equation with numbers on the table in order to get the corresponding values of y. So where x is equal to minus 1, we substitute minus 1 into the equation, we have y equal to 6. Where x is equal to 1, we substitute into the equation, we have y equal to minus 8. Where x is equal to 3, we substitute into the equation, we have y equal to minus 6. So until we get to the last one where x is equal to 5, and when we substitute, we have y equal to 12. Okay, we have successfully completed the table. That's the completion. We filled and complete the table. So next, we'll go to plotting of the graph. First step is to import our table of values, which we just filled. Next is for us to draw our y and x axis. Always remember to label your axis, y and x, as shown on the screen. Next is numbering the x and y axis according to the calibration range given in the question. Let me throw more light on the axis calibration. Let's zoom in the graph. On the y-axis, 2 cm to 5 units. Bear in mind that each of the box is 1 cm, so 2 cm gives us 5 units. That is, when we have 0, next will be 5, next will be 10, 15, and so on. On the x-axis, 2 cm to 2 units. And when you check, when you have Each of the bus is a 1 cm, so the 2 cm is to 1 unit. After 1 we have 2, 3, and 20 lines gives us 1 line gives us 0.05. Now let's plot our graph. Carefully, let's plot -2 on the x-axis and y 19. The next one is -1 on the x and 6. Let's zoom in so you understand how we'll plot it. So you can see -1 and 6 on the y-axis where it join together. Then let's plot the remaining points: 0 to -3, 1 to -8, then 2 to -9, 3 to -6. You can see how the points are emerging. 4 to 1, and lastly but not the least 5 to 12. So let's join the lines. Remember, you're joining this line with either your French curve or the flexible curve ruler or your local broomstick. So from the graph, the minimum value of y from our reading, we have y equal to -9.125. Then the next is for us to get the gradient of the curve at s equal to 1, and the gradient is change in y over change in x. So at the x-axis we've drawn a tangent gradient, so we'll find the gradient, and taking our value change in y is -12.5 minus 5.0 all over 2.5 minus 0, and we have -3. So the next is for us to plot the linear graph so that we can find the solution, and that solution is the point where the two graphs meet together. So we filled the table, completed the table using the equation y equal to x plus 4. So we just plot the graph. It's just a straight line graph, and we'll join the line, and the next we'll find the intercept, and that the intercept of the two graphs is where is the solution of the equation. So we'll read the values. The values there is 4.7 and -0.7. Thanks for watching. See you next time. Please don't forget to like, share, and subscribe to my channel.